Okay, so don't forget that all these problems are released for this Bell quiz. So if you wanted to try it again, just write down AB Calc 2006 question 6, and you can try it again if you want to see it. You can find them real easily, okay? Okay, I stamped 3 things. I want to kind of go through it methodically. So first I just want to stop, and are there any questions you couldn't figure out for your corrections from AP Central you want me to look at? Is there any questions you guys have from AP Central? Anything? 27? Yeah.
Oh, yeah.
Okay, so in order to do this one, you had to remember something many of you probably blocked out. Michael, can you stop that?
Sorry.
Like, I'm going to. Probably blocked out this word, dilations. Basically, all you need to know from that word is the fact that if I were to do this, right, I have 2 similar triangles, here and here. That's kind of the trick to the problem, okay? So let's say it says a person is 6 feet tall and the lamppost is 15 feet tall. Luckily, neither of those lengths are going to be changing in the problem, right? And then the person's walking this way at a rate of 4 feet per second. So let's call this length here x. It needs a variable. It's a changing length if they're walking that way. So dx dt would be 4, okay? Now the question's asking for what is the rate at which the person's shadow is increasing. I'm not going to use s because my s's look like 5, so I'm going to use h. So I'm looking for dh dt in the problem. Does that make sense? Doing okay? Okay, so the first step always with related rates is to figure out an equation that represents how our dependent variables can compare. Sometimes we use Pythagorean theorem, sometimes we've used sine and cosine stuff, right? In this case, because one of the triangles is inside the other, we're going to use ratios. So it's like kind of like the fact that they're dilations tells me that this length is to this length, right? Okay, so one way you could do that is this. 6 is to 15 as h is to x plus h, right? Then another way I could have written it is maybe h is to 6 as x plus h is to 15. You remember with similar triangles, as long as you're matching up the pieces right, there's like always multiple ratios you can do, right? Well, that's a good thing because the next thing I need to do is derive this. I don't feel like doing the quotient rule. Who ever does, right? So I don't want to use that one. Not that I couldn't do it and it wouldn't work great, it would. But I don't feel like doing the quotient rule, okay? So instead, I'm going to do the derivative of this one because it's a much easier equation to derive. Right? So I have 1/6 times 1 dh dt equals 1/15 times 1 dx dt plus 1 dh dt. Just a bunch of linear deriving, right? And I can always take a coefficient and just deal with it at the end with derivatives. We doing okay? Stop here. Any questions where I'm at so far? No? It's okay if the answer to that is a yes. But what is not okay is to ignore Miss Summers' yes or no question.
What is 1/15?
Okay, so 1/15 is from me taking the coefficient out. See how this is over 15? So I took that
Oh, so you're just
coefficient out, so I don't have to do any kind of a quotient rule when I derive. Does that make sense? Okay. Good? Anyone else? Okay. So I know dx dt is 4. And now I have one equation and one unknown. And you've got your calculator, so you can distribute the 1/15th, get the dH dt's on one side, right? And solve it from there. Is that good? Okay. Questions? Okay. Other questions on the AP Central corrections you couldn't figure out? Okay, bookwork. Any questions on the bookwork you want me to go through?
uh, 46.
46? Okay. Do I need to go through endpoint right and mid, or is there just one for 46? Huh?
Yeah, midpoint.
Midpoint?
Yeah.
Okay. So it says here that use the table of values to estimate 0 to 6. Use 3 subintervals of equal length. Okay, so if we do the midpoint one, okay, then I know that wait for it, 3 subintervals of equal length. So we have this, anytime they say the subintervals, remember, are, does it even say equal length? Use 3 equal. There we go. It's like, where's that? That to find the length of our subinterval, we use this formula, right? So I'm going to take dx is going to be 6 minus 0 over 3. So my dx is 2. So I know I'm going to want each rectangle to be 2 wide, right? Is that all right? Okay. Then for a midpoint, I know, so if this is my rectangle, its base is 2 and its height is determined by the middle value in the interval. So 0. And this one is going to be 2, because it's 2 wide, times 18, because 3 is the middle between 2 and 4, plus 2 times 50. So 36, 136, right? Is that what you got? Okay. And then f of x is increasing, but that doesn't necessarily tell us how the midpoint one is going to compare. So I honestly would probably just say we're not totally sure. We know this is closer, but we need to know about its concavity to determine how close the midpoint one is. Something like that is fine. Okay. Good. Anything else in the bookwork? You guys, it's been like this all day. All my students are just mentally not present. I need you to perk up, okay? I get it. I snoozed 12 times today. I don't want to be here either, right? But we got to get through it. Wake up, right? We're all focused and actively paying attention with our notebooks open and the homework I just stamped out, okay? Right? Okay. It's okay if you don't have questions, but when I ask a yes or no question and you just stare blankly at me, that's the problem, right? We're wasting time for the calculus stuff, okay? So do we want to go through anything else on the bookwork, yes or no?
No.
Okay, again, it's okay if the answer is yes, but I don't like being ignored. I like the attention. I'm a teacher, remember? Okay? Okay, last one then, worksheet. Anything on the worksheet you guys want to go through?
The second question, part B.
Part B?
Yeah.
Sure. You felt like it was so easy it couldn't be right?
Nope.
We've all felt that before, right? For real.
No, like, yeah. I did it, and then I was like, I checked it, and it wasn't the right answer, but I couldn't figure out why.
Probably the word average, but we'll talk about it.
Oh, yeah, but you.
Okay, so, second one, part B. Alright, so I know that I have this. Okay, it says use a trapezoid sum with 3 subintervals. Okay, now it doesn't say anywhere in there that they have to be equal. So that tells me to use the data in the table, which means my dx's might be different, and that's okay. All right. But then it says to estimate the average number. We'll deal with that word later. Number of people waiting in line during the first 4 hours. So that means we don't care about any of that. Okay. So first trapezoid. That actually makes it easier because if I want 3 subintervals, then I know there's my 3 trapezoids. Right?
Yeah.
Now, if you can do it without kind of plotting points to see what's going on, that's fine. I'm just going to do a quick kind of sketch for that first one at least. So I know it goes from 0 to 1, right? And at 0, my graph's up here at 120. And at 1, my graph is up here at 156, right? So this trapezoid is going to look like that. So if I take my trapezoid formula, my 1/2 height times base 1 plus base 2, my height is my dx value, which in this case is 1, right? Plus 120 plus 156. Notice that I didn't need to draw the picture out unless I needed to visualize. These problems I feel like you can get right. So it's worth taking the time to draw it out if you're concerned about what's going on, okay? Any questions on the first trapezoid from 0 to 1? We doing okay? Okay, so then let's do a better marker, because I deserve a better marker. Oh, thanks. 1/2 times 2 times 156 plus 176, because this next one goes from 1 to 3, and then those are my 2 heights, right? Plus 1/2 times 1 times 176 plus 126. I did this problem last class. I think it ends up being 691. Is that what you guys got? Anyone on your papers? Because that's from memory.
I got 621.
Ah, close. That was close. 621.
Yeah, I think I just plugged in my calculator wrong, because that's exactly what I did. I just got it.
Oh, that'll happen. But luckily, you'd still get the point for doing a trapezoid sum. You'd still get the point for hopefully doing the average. We'll take care of that word here in a second. So the 621, remember, is representing the integral from 0 to 4 of L of t dt, right? Or I guess I should say it's my approximation of that, right? Think about the word average. Like, think back to, Nick, can you stop? Sorry, I'm like, my ADHD is like crazy, so like I can hear every little like drip, drip, you know what I mean? Okay. So I don't know what I was talking about. Oh, average, think back to average. Okay, you add up the total and then divide by how many there are, right? Okay, so if that's my total, the average just means I then take that and I divide it by 4. Right? Total divided by how many there are, right? Does that make sense?
Yeah.
And I'd probably just leave it like that. Does that help? Yep. Anyone else on the worksheet? Okay, notes and ultra lavas out. gonna use our ultra lava today. We're gonna make a new table on the back. Oh yeah. Amelia, will you turn the lights on? Gracias. Okay, today we're doing integrals, day 3, integral properties. Oh, that's okay, do you guys all need to stand up and like get your wiggles out, or are we good? For active participation in the lesson to make it go faster?
I think we should.
Okay, stand up, everybody stand up. Stand up. Carter, you want to leave us in a yoga move? That's what I thought I'd say. Okay, do a stretch. Okay, everyone knows this 3-day week has been the longest one of the school year so far. Right? Okay. This 2.5-day week is the longest week of my life. You got 45 minutes and then you can go and play Lego Harry Potter until your heart's content. Okay? Good. Okay, we're gonna get through it.
That's kind of boring inside.
Okay. Okay. On the back of your ultra lavas. Right now, hopefully about the only thing on the back is your derivatives table, right? You need to leave some room over here for an integrals table. We'll start in a couple weeks. So around in the middle, we're going to make a new box. And it's going to be called Properties of Integrals. Okay, it doesn't need to be the whole column. All right. Probably similar to our derivative characteristics one. Maybe a little less. We have like 6 or 7 of them. If this is a great time in the year, as you guys are starting that table over there, to think about redoing your ultra lava. You don't have to, but when you rewrite it, it helps you memorize it better. It's great to reorganize it, but even more important is rewrite. The more times I rewrite something, the more you remember to do it. It also helps you kind of remember like where it is on your study sheet, so it's easier to find. And then honestly, that's like a study tactic on a test. If I'm trying to remember a rule, if I can think about the placement of it on a worksheet, sometimes that'll help me actually remember it better, okay? There's always blank ultra lavas there you can get. And remember, I did post a couple ultra lavas on Canvas that are up to date until the very start of integrals, okay? That you're welcome to go on and see if you're missing anything, okay? So keep that in mind. All right. Let's get through a couple easy ones first. Put it on your ultra lava if I write it over there. Okay, anything I write over here goes on your ultra lava. What do you think? What do you think that's the same as? Nope.
Maybe it's just equal to x. Yeah, let's just
0. There's no
area.
There's no area. That's a single dimension, right?
Yeah.
Give it like a straight line. It's like a rectangle. Make sure I get that on video, my quotes. It's not a rectangle. It's a rectangle, right, with width 0, right? No time is passing. So I can't find any area of anything. Make sense? Okay. Okay, next one. What's the difference between the two things I wrote?
You swapped the A and B
I
and
swapped the A and the B. Okay, good. Think about it like this. If from 0 to 1 second, Superman flies into the air, he's going up, right? But if I rewind my Marvel movie, what direction is Superman traveling when I go from 1 second to 0 seconds? Down, right? Oh, sorry, is Superman not Marvel? That was what the discussion was over here. They were more worried about that. Is he DC? My bad. Sorry. Okay? But the whole point, remember, is integrals are signed area, plus or minus sign, right? Signed area. So direction matters. Okay? So if I'm going back in time, then I'm moving the opposite direction. Does that make sense? Okay? Also, just like teacher moment in my head, that's probably the first time I've used that Superman example. That made sense, didn't it? It's pretty good, huh? And I got it on video, so sweet. Okay, next one. We're going to talk about over here for a second. I want you guys to find, well, we'll do this together. Here. Now, I don't need to approximate this one using a Riemann sum, because when I graph this shape, you see it's a triangle. So why would I approximate it using rectangles when I already know this geometric formula? Is that fair? Okay. So what is the exact value of this integral? 2. So 1/2 base times height, right? Does that make sense? Any questions? Okay. So then what happens when I do that?
it does it become 10?
It does become 10.
Yeah.
Okay? Because I'm just doing 5 times the area under this shape. Does that make sense?
Yeah.
Now, here's my question. I want to know what happens with that. I want you guys to try and come up with a visual representation about what's happening between the two integrals. Okay, so work on that with your neighbors for a second.
Instead of the exact
So find for me that integral and come up with a visual representation comparing the two integrals.
It would be like, yeah, just. And the answer would probably be something like 5. It would be 5.
Yeah, the slope is fine. Alright, the slope is fine.
Because the graph now goes up to 10. X equals 2. So you have a really long triangle. And the area of it is 5.
D of x is the length of my subinterval. So when we're doing an exact integrand, right, the dx is representing
Nice.
the width of the subintervals as they get infinitely closer to 0. That's what's making it an exact integral. The equation is the height of the trapezoid, f of x. The dx is the width of the trapezoid, or the rectangle. I would write it the real way, just to, yeah. But will you go draw your picture? Carson, no notes today? Oh, okay. Oh.
So it's just, in this case, we're just saying that it's or dx is just, yeah, find the example. Okay. Should be strong.
visual representation, right? Okay, thanks Josie, that's good. What am I trying to get at?
The same. I thought that they were gonna be different.
Spencer, what are you saying over there?
I thought that they were gonna be different, like, areas, but
Yeah?
it's the same area.
Oh,
Ah,
I'm a little.
okay. Well, hold on. Someone put this together for me. What am I, build on what Spencer was just saying. What am I trying to get at here? Come on, peeps.
What's a variable I could use for, like,
What's a variable you
I
could
could
what?
use, like, well, in place of 5, I could use, I guess.
Oh, so what's a variable that we utilize sometimes in calculus to represent an unknown number but not a variable? K.
Okay, so you could do.
Okay. Get it?
That's
Ah.
a good one.
Yeah, okay, go ahead, Spencer.
Okay, you think I could actually write it?
I would love for you to go write it out. Are you kidding?
Bro, I'm
The
actually
answer to that question is always yes.
putting stuff together. Okay.
So
I'm gonna write it under here or like just.
I'm feeling like you got it. Go ahead and write it over there.
Okay.
Look at that.
So we got. Oh wait, hold up. That's B. There's an eraser.
Just use your finger, it's fine.
Okay. You're
I
not.
mean, it's
as-
not great.
You're not as strict as Burton about her whiteboard. Okay, and then we got.
Oh yeah, I know. Some teachers are so strict, huh? It's because your oils get on it or something. I don't know.
She would not take me to
Ew, she was really mean about it.
Well, it's because then I don't know which teacher you're talking about. Don't say it. I'm recording. I'm just saying I understand why though, because then you have to like clean it all the time. But that's, I mean, TAs do that, so
Okay,
it's
and
fine.
then, so I'm doing this really slow, but you know I'm taking my time. It's fine.
Is what he's writing out similar to any of our derivative rules? We had a coefficient derivative rule, right? In fact, I used it on the dilations related rate problem earlier today, right? I took that 1/15th out and put it on hold. You can always just take the coefficient out. Very good, Spencer. That's correct. Okay, that will always work. Okay, as long as K is not variable. Isn't that weird in math? We like replace all of our numbers with letters and now my letters represent numbers. What is happening, right? So that's a numeric, any number, but can't be a function. Okay? Very good. Questions? Anything? Okay, next one.
Miss Summers?
What's up?
Does it matter what order you put like the B and the A? Because they're just variables, right?
Yes, it does because we define our domain always as being from smallest to biggest, A to B.
Okay.
So basically what that's saying is because when we do this in the real world, we're talking about time. So we're specifically saying A is our starting time and B is our ending time. So it's moving forward from A to B. That's why it makes it opposite when I switch them here. Now, does it matter which one I call A, which one I call B? No, but conventionally, as like mathematicians and like Padawan mathematicians, right?
That's how they define
That's how we define it so we don't get confused.
Okay.
I always get a laugh out of my Padawan joke. Not today. You're not going to give me that today. Thanks, Sid. Thanks, Sid. Yeah, come on. Guys, my humor is my classroom management. It's how I pay attention to who's listening. Okay, come on.
Dang.
All right.
Smart.
Yeah. Yeah. Okay.
I heard it just didn't really. The joke just didn't really quite cross my mind.
Oh, well, if you have to
I
explain a
was
joke, it's
listening.
not a very good one,
It
okay?
was just. It was. Hey.
It's fine.
I won't-
My dad always said as long as one person laughs, even if it's just you, then that's fine.
That's fine. Exactly.
Mhm. Okay. I would like to know now.
Oh my God. Yes.
Those numbers are too big. those weren't the numbers I'm talking. Okay, I'm gonna give you a couple minutes with your neighbors on this one. And I'm gonna randomly call on someone in class. I would like to know how to rewrite this one. This one's just didn't know someone wrote this one here. I want a visual representation showing how to rewrite this expression in one integral. Oh, think about it. You can do it. Okay, I want you to rewrite this expression in one integral, and I want a visual representation showing how to do it. Oh, after the last two minutes, I've gotten closer. Put the notebook in front of you, right? Do you want me to open it? Oh, okay. But Andrew leaving out Carson, the sassy one in class? What's happening here? I don't even know.
Yeah. Unless it's, yeah, no, it's literally 2x plus 1.
I'm gonna get a good visual representation of this group. I mean, look at that windmill doodle. And that's incredible. You know, the shading of that windmill doodle is impeccable. Is there, okay, I really like it. I'm not gonna say right or wrong because there's no right answer to this open question. But that makes sense to me. I like it. So now, and then you're ready to yeah? All right.
I guess it's trying to be slightly like this.
Try to be more particular away from vocabulary. There's no right or wrong in life, right? But I like it. Visual representation. It makes sense to me.
So I trust Roddy.
It's wait, it's half times height. So height, so 1/2 makes 2. The base one is 16. 16 kg per pound.
And I should set it up on the
And I'll cut everybody some slack today. Come and draw your picture.
Done.
I won't do a random number generator like I was going to.
I am so.
Okay. No, I just asked you to. Because I saw her picture and I like it.
I think you should.
We do that, we do it a lot, but not yet. Not when I never know if I'm not gonna see you next time, so I wanna get through content, you know what I mean? In normal years when I can assume I'll see you guys next time. First semester, it's like we never knew if Summers was gonna be here the next day, and now it's I never know if we're gonna be here all the next day, who knows, right?
Yeah.
All right, we're all in it together.
Do we put the school board aside?
They didn't decide anything, they put it on hold to their meeting on Tuesday.
They were.
They couldn't come to a consensus.
So are we?
Okay. There's no decision has been made either way, and it won't be till Tuesday. Okay, do you guys see?
Yeah.
This makes sense? The idea is that if I'm taking this area, right? And then this area, they don't conflict with each other at all. Does that make sense? Right? So then I can go all the way from 0 to 5. Does that make sense? Okay?
Yes.
Now, there's a couple, what's the word? Let's see if you guys can come up with it. Using this idea here, okay, I'm going to do a different one. You can do a visual representation if it helps you, but I want you to consider this. I agree with what's on the board, and I want you to tell me what you think would happen. Again, similar idea.
Oh, I got it. I see it.
And you combine that to one integrand. Or tell me something that's equivalent to that. Visual representation if you want.
No. Ooh.
But I want you to think about what Emily put on the board, which is correct.
Oh, this is.
Okay, in terms of her integral. and I like the visual representation. And I want you to think, how can I apply that idea to this one? To combine those into a single integral. Anyone want to go try and write it up on the board? Sid, go ahead. Use blue, black, or purple.
You just want me to write this, what the answer
It did for you? Really? Oh.
Like you just
Oh, really? Maybe it depends on how much ink is in the marker then.
wait, you said blue, black, or what?
Just whatever. Blue is fine. Do you see it?
So you just take that area out.
Mm-hmm. Does that make sense? Because then this idea is like I have the whole amount and I'm taking out part of it, so I'm just left with whatever's left over in the domain, right? Wait from -1 to 2. Okay, this will always work as long as one condition is met. Anyone think they know the condition? No, you can do something similar when they overlap. Yep.
As long as the function is the same.
Equation has to be the same. Has to be the same function so that I'm comparing the same shapes. Okay, good. Okay, let's add this one. So, integral. Okay, last one. I want to know, and I'm going to give you a second to talk with your neighbors and maybe try some examples on your, kind of exploring your calculator a little bit. Okay, so again, I'm going to give you a minute with your neighbors to come up with some problems to try and explore in your calculators. But I want you to rewrite that into a single integral expression that's congruent. Actually, I should say equivalent. Congruent is shapes that are of equal measure. Equivalent is numeric. I've decided to be tough on my vocabulary usage. Okay, good. So kind of mess around on your calculators, explore a little to see if you come up with a hypothesis. I want you to come up with an example or two that shows. If you think, I want an equivalent integral expression with one integral. See a lot of you mess around your calculators. Good job. Talk with your neighbors. I'm going to take a volunteer here in a sec. any thoughts? Carson?
You can add g of x to f of x inside of the function.
Yeah, you can. Very good. So where this one would have helped on your homework last night, in that problem you had, it was number 47. It was the one where like the shapes looked like this or something. I don't know. You know what I'm talking about? Something like that. Anyway, one of the parts had you do the integral from -4 to 6 of f of x plus 2. So one way you could have thought about that, and some of you may have done that inadvertently without even knowing this rule, is you could have taken this and you could have split it here. Then what makes that nice is that this one is actually a really easy integral to find because it's just a rectangle, right? It's 10 wide and 2 tall the whole time. So you could have found your area of this and then just added 20 to whatever you got there. Does that make sense? Okay. So what the purpose of these properties of integrals are to make you can do some rearranging to make whatever you're typing in or the geometric formulas you're finding by hand easier. Does that make sense? Turns out this one also works with subtraction as well. Okay, I don't feel like rewriting this one over here, so that's the last one. That's our last property of integrals. We're doing okay? Yeah? Okay, we're moving on to something different. As soon as you get these on your integrals, for properties of integrals table. Okay. And then you can put your ultra lavas away. We don't need them anymore today. And that's how I'll know you're ready to move on. Look at that, another classroom management strategy. Boom. Know you're listening when you put it away and you're ready to move on. That's all I'm trying to do is I'm just going to try to inspire the youth of tomorrow. You know? Oh, thanks, Carter. Okay. Questions? We're doing okay? Okay. Next thing we're going to start talking about, we are going to spend a lot of next class talking about this as well. But I just want to start the idea. Okay? So go ahead and okay? Wait. No. -2? Yeah. Okay. What is wrong with my coordinate points? Better? Okay. second to finish writing out those. Well, that's just annoying. Where did I do that? There. So much better. That makes perfect sense, right? Okay, before I actually want you to try answering these questions, I'm going to give you a minute with your neighbors, and all I want you to discuss is this. Are those asking the same thing? Talk about that with your neighbor. If they are, why? If they're not, why not? Are they asking the same thing?
Yeah.
Same thing, maybe in a different way.
Yeah, you should get the same answer. We were missing. One's asking for area, one's asking for line. They'll find the area from, but see.
Yeah, so what I'm saying is when it starts to find areas that don't have then that's when we go to one of the areas to just the area that have some. So would you actually, you would add that in the plan? Yeah, you have to add everything. Whereas number one would be, that's part below it.
Okay, let's come back. What do you think? What are you talking about? Are they the same thing? Sid?
Oh, I think that number, like, so when you use the integral, it uses the signed area, but then when you use the area, like in number 2, it would be the absolute value.
Okay, hold on. So yes or no? Do you think they're the same thing? No, she's correct. They are not the same thing. Okay? And it all has to do with the signed area. Right? Remember, area, think back to geometry. It didn't matter what orientation, the triangle, the trapezoid, the circle. Haha, that's a joke because circles all have the same orientation. Okay. But it didn't matter, okay, what orientation the shape was in. You use the same area formula. Area is not negative. It's like distance, right? But integral is signed area, meaning kind of like directional area. Things below the x-axis are negative, right? So which one of the answers to those is going to be a bigger number?
Area.
With 1 or 2?
Two. That's what I said.
Number 1 will be bigger.
That's right in the first
Number 1 will be bigger. Okay? Does that make sense?
Yes.
Okay, now find them.
Oh!
Bet.
Find them.
Let's get to work.
Find them, and I want an integral expression for each one. Find them, and I want an integral expression. Okay? Find them. I want the numeric answers and the integral expressions.
Is this saying negative 1/3 0, or is that supposed to be negative 3?
Well, I think it's negative 1/3. Isn't that where this equation would cross the x-axis?
Okay, yeah.
I think so, right? Okay.
Sorry, yeah. I was,
No, you're good.
So it's because finding the area. Remember, area no matter what orientation it is, you can't have a negative area. Also, the integral if it's underneath 0, it's negative 2. Negative. Area. Oh yeah. So number 1 is just the overall. Number 2 is like actual. So,
thank you.
equation. I guess we could use triangles, but we have to use integrals.
You can use triangles to find the areas. I just want an integral expression representing
Sounds good.
the area.
That's a lot easier. Right.
Spencer, do you see the difference? Do you understand the difference?
Yeah.
Okay.
Bless you.
There we go.
Bless
Negative. So it's 2 and a third. Divide by 2.
Wait, so we're trying to find a unit.
So if we just go 7 thirds, so we've got 3 on the and then calculators and find
Chris, you're messing up today. Now you have 2 different notes.
This is.
He's double down.
You're messing me up today.
Double down.
Now he's got 2 notebooks. What on earth?
Yeah.
Oh, okay, okay.
So that's the area of that one, and then you gotta find the area of the one, which is 2 thirds.
So basically just solve that using areas.
It's a third.
Find their solves it on that.
It's 2 thirds.
Okay, so
Oh, well, yeah, for the full area, it's just, yeah, that's what I'm saying, shit, 1 third. Full area.
No, it's like like the first.
That's only going 1 down. Oh, wait, it is going 2 down. Oh, yeah, it is. Oh, so it's 2 thirds. And then you can choose that to 6.
So 1/3 was 1/6.
No, it's not negative, it's just area. So yeah.
Well, I thought the area of this, and then I got, yeah, the area of this, and this.
Number 2. So 2, 3, 4, 5, 6.
53,
Don't look at me.
for number 2. Then integral expression. So we got from that about all I have to do. Right, so like this from 2.
How did you get to number 1?
Wait, wait.
6 plus 6 plus 3.
This little triangle is
I did something wrong. Oh no, I know. I did it wrong.
for 15 halves.
Equal to 55.
Okay, I think I got
Okay, fine,
Yeah, that's you got the point to subtract to them. Bro, honestly, it's pretty much the same thing except you're adding instead of subtracting.
Oh no, it's Bob. Wait, no, it's not.
So that's gonna be just the same. It's like the same, but if you get one spot. What's the adding or subtracting?
5, 6. I got 8 and a half.
8.8.
What did I do wrong?
Anyone want to come up and put what they got for number 1?
I did.
Okay, come on up. What about number 2? Anyone want to come up and put number 2? Amelia?
Write the integral expression.
If you can, that would be great.
Alright, and do you want me to write my prior active work as well?
Yeah.
Yeah. Actually, I'm gonna do, does the red show up good?
Probably not. Don't use red. You can use purple or blue or brown. There's brown.
Okay.
What am I doing? I'll just see what these people do.
Is that on? Okay, that is on. You can. Okay.
That's what I'm saying. Wait, no, it's not what I'm saying. I thought I was okay. Oh, okay, you know that's probably right.
All right. Ready? What are you guys thinking? You agree?
Yeah. Looks fine to me.
Okay.
Yeah, but the integral for this first one would be
So when I type this into my calculator,
it gives you 15.
which number does it give me? And it should, because the calculator thinks the integral is the signed area, right? So this is, and type it in now too, right? So this is the integral from -1 to 2, 3x plus 1 dx. It should give you the 15 halves, okay? And if you didn't try it before, try it now. I want you to see it, right? Okay? We have to manipulate part of it. Okay? Anyone have any ideas? Yeah. Sid's answered one today. Go ahead, Carrie. Come on. Oh no! I still want you to write it because I wanted to take a picture. I didn't get this far. B7 ended like a minute ago, so.
This felt very short.
Really?
Yeah, it's
So
still
like this is like 5 minutes.
For me, it felt
hours.
like a week. Oh, that's clever, Carrie. She switched the A and the B. I did absolute value bars when I did it in my head, but she used one of our properties we learned today.
Yeah.
So instead of going from -1 to -1/3, she went from -1/3 to -1, right? Because then that makes it negative and it's already below the axis.
Oh
Clever.
my
I'm digging
God.
that. Yeah, that'll work.
So smart.
I'm digging it.
What a genius.
Yeah, cool. Hey, homework is bookwork. I already texted it out, but it's right here if you'd rather write it down. Great work.
See you guys. See it. See which one it lands on at the end of the year.
If you want points back, turn them in.